Oh, hello, hello. How's everyone? I reached 6.1 progress, and yeah, let's get into it. I'll start with Need for Speed. Alright, creating an instance of a class is done by calling its constructor through the new operator. A constructor is a special type of method whose goal is to initialize a newly created instance. Constructors look like regular methods, but without a return type and with a name that matches the class's name. So basically, if you have a class library, the constructor is called so-called library. Of course, it's public, and you can do stuff, right? Initialize stuff. And then you just do new, the name of the constructor or the class, whatever, and yeah. All right, like regular methods, constructors can have parameters. Constructor parameters are usually stored as private fields to be accessed later, or else used in some one-off calculation. Arguments can be passed to constructors just like passing arguments to regular methods. So, if you have a building, the building has a number of stories and a total height, right? Height. Okay, so the constructor takes these two parameters to initialize the number of stories, and the total height is basically, yeah, it's basically calculated because the parameter is actually the height of the story, of one story. So you need to multiply with by a number of stories. So yeah, and you get this, right? Okay. Instructions. Let's get into the exercise. In this exercise, you'll be organizing races between various types of remote control cars. Each car has its own speed and battery drain characteristics. Why do I feel that? Anyway, sorry. Cars start with full 100% batteries. Each time you drive the car using the remote control, it covers the car's speed in meters and decreases the remaining battery percentage by its battery drain. If a car's battery is below its battery drain percentage, you can't drive the car anymore. Each race track has its own distance. Cars are tested by checking if they can finish the track without running out of battery. You have 6 tasks, each of which will work with remote controller car instances. Okay, so creating a remote controlled car. Okay, let's go back to the editor. So this time I have zoomed in, so it's a little bit better for those in small screens, or where you cannot basically watch the video in full screen. So yeah, we need to define the constructor. I think the first one, yeah, first task. Allow creating a remote controller car by defining a constructor for the remote control car class that takes the speed of the car in meters and the battery drain percentage as its 2 parameters, so both of type integer. Okay, yeah, battery drain speed. Okay, let's do it. Yeah, public constructor, so it's public remote control car, int speed, int battery drain, and what we want to do is basically, yeah, so let's also define the private fields. So it's private int speed 0, right? Private int battery drain. Let's say the default is, yeah, whatever. Let's see if this works. Line 1, what? I don't know why this doesn't work, but let's... Need for speed tests. I cannot see the results. Why? Is it the zoom? Anyway, let's do number 3. Creating a racetrack. Allow creating a racetrack by defining a constructor for the racetrack. Wow, that was totally random. The fact that I knew how to name the argument, I imagined that a racetrack has a distance or something. I don't know. Anyway, so this, sorry, not this, private int distance. This distance. Run tests. I don't know why I cannot see the passing tests. Was there like a change or something? Anyway. Drive the car. Implement. Implement the remote control car drive. Okay. Drive. Drive method. Where is the drive method? Drive. Okay, yeah. That updates the number of meters driven based on the car's speed. Also, implement the remote control car distance driven to return the number of meters driven by the car. So speed is 5. Yeah, speed is 5. Car new speed. Car drive. Yeah, distance driven 5. Okay, so let's first initialize a private field distance driven 0 to 0. Okay, so drive basically is distance driven plus equals speed, I think so. And distance driven is basically distance driven, right? Okay, task 3. Why do I only see the third test, passing test? Don't know what's going on. Test 3. Anyway, check for a drained battery. Update drive method to drain the battery based on the car's battery drain. Also implement the battery drain method. So basically battery drain to car drive, battery drained false. Oh, okay. So maybe this is 0, private and battery percentage 100%. So if it's battery percentage, so drive basically, now I need to have a body. So this is basically if the battery percentage equal or below 0, then this should be true. No. Let's see. I think if it's drained, if not this battery drained, then so what's this? If speed is 100 and battery drain is 60, Oh god, I don't understand this one. Speed, okay, so speed is 100, right? Speed is 100. Battery drain is 60. Okay, so speed 100, battery drain 60. What does it do? It drives. Okay, is the battery drained? No, so it will go here. Okay, so distance will be 100, and battery percentage will be 60. 100 minus 60. Which is 40. I think I'm missing something from the instructions, possibly. Car start with full 100% batteries. Each time you drive the car using the remote, it covers the car's speed in meters and decreases the remaining battery percentage by its battery drain. If a car's battery is below its battery drain percentage, if a car's battery is below its battery drain percentage, you can't drive. Oh. Each racetrack has its own distance. Cars are tested by checking if they can finish the track without running out of battery. I think this is the key here. If a car's battery is below its battery drain, yay. I wasn't as excited as the sound effect, right? Yeah. Anyway. Whatevs. All right, create a Nitro remote control car. Sorry, go back. Yeah, task number 5. All right, the best-selling remote control car is the Nitro, which has a stunning top speed of 50 meters with a battery drain of 4%. Implement the static remote control car Nitro method to return this type of car. Yeah. I'm adding a couple of hotkeys to play sounds. Haha. All right, so let me try this now. Yeah. Okay. Let's go back to the instructions. Okay. Let me drink some coffee. Okay. Check if a remote control car can finish a race. To finish a racetrack, a car has to be able to drive the track's distance. This means not draining its battery before having crossed the finish line. Okay, makes sense. Implement the racetrack try-finish track. Okay. That takes a remote control car instance as its parameter and returns true if the car can finish the racetrack, otherwise return false. So let's say the speed is 5, the drain is 2. Okay, let's say the distance is 100. Try finish the track. Okay. So basically, what do we need to do here? I guess this is a stupid way. No, I don't want to drive the car, right? Well, I guess distance, all right. I guess maybe I can drive it, right? While Is this the syntax? Let's ask ChatGPT. To define a property, define the private field. Sorry. Maybe this works. I don't know. No. Line 10. Yeah. Ah, sorry. Is it int? Public int speed. Forty-one. What? The name cover distance does not exist, of course. Cover distance 0. So we have, so this works, but we have a let's remove the these comments. So the speed is 10, the battery drain is 2, distance is 100, race distance, assert true, try finish track. Expected true. Why? Where debugging? How to debug when test fails? When a test fails, the message is displayed describing what went wrong. You can also use the fact that any console output will be shown too. You can write to the console using. Okay, so let's basically. Let's see. Where's the output? Okay, so let's go. Is car battery trained? True and true, right? No. What the hell? Is this it? Yeah. Well, no. I have two failures now. At least. Speed 3 battery. Speed 3 battery drain. False. Expected false, actual true. Why? I think I'm gonna do it in a different way. I mean, sorry. Someone's how do you sub? I don't see. I guess I can try to calculate so can cover distance basically is the distance. So if we have like this one and speed, speed how many times does this need to drive? 10, right? 10. So 10 multiplied by 2 equals 20. So 20. So 20. So 20 equals 80. However, let me try this instead, because I was trying to be like a smart ass. hey. So I think I got this right, but I guess the tests will tell us. Is it only one? So what is going on here? Let's see. So this expects that this is basically true. Okay. All right. So speed is 2. Let's do the calculations here. Distance is 20. Okay, so this is distance is 20. Distance is 20. Speed is 2. Multiplied by battery drain. So this needs to be greater or equal to battery drain. So this is 10. So this is 0, right? So 0 is not. Oh God. I don't know what is going on here. So if we have if we have this distance, then the car needs to drive. Yeah, what the okay, so again, I need to really understand this. So basically the car needs to drive 10 times to reach, okay, that distance. And the battery drain is basically, what the fuck, I mean, it would need 100, right, expected true. Oh god, why? Car can finish with car that can just finish. I don't know. I'm confused. I think I will yes, this is what I tried to do, but yeah, I don't know why. Remember that the car has a method to retrieve the distance it has driven. Consider what to do when the battery has been drained before reaching the finish line. Should I do it like that again? I don't know. Oh, I see. Okay, so I think I understand what the problem is. I think the problem is that this test checks if a car can drive can cover the distance right at the point, like can both fully drain the battery, but reach that point. So so I guess what we can try, maybe, I don't know, how do you do this? Is this the correct syntax? Do car drive if car battery drained, return false while Why is it so difficult? I mean, my brain is at fault here, but maybe I can reverse this. Yeah, finally. Oh my god. I'm not sure why I'm happy, but yeah. Yeah, and then I guess the reason I'm using a new instance is because I don't want to mess with the state of the current instance. So this is a temporary car that I'm using based on the current state of this car, and I'm trying to drive it and see if it can reach, it can cover that distance. Anyway, yeah. By now you have probably solved this 1,000 times, but yeah. Guess it took me so long that I don't want to like start another exercise. So yeah, I think this is it for today. All right, let's submit. Oh, maybe I have some feedback. Let's see. No immediate feedback. Wow. Yeah, maybe I'll spend some time looking at other solutions, right? Let me see. Community solutions. Wow. Oh, there is a way to do it. Let me see. Okay, so wow. Everyone is doing this basically. Possible distance. Yeah, this is what I tried to do without driving it, but I guess drives multiplied by car speed, possible distance greater or equal this distance. I guess the difference here is that, yeah, the difference is that if you use the car, like an instance of that car, and use drive, you are not, I guess, duplicating logic. Like drive is a black box, right? Like you're not duplicating logic here. So if anything changes inside the car, then this is probably depending on that, like influenced by that change. Whereas if it's calling drive, so yeah, although it's a nice and fast way to reach the conclusion here, it's not my favorite approach. So I don't know why mine is so complicated here. My brain is to blame, but these solutions are, so for example, this one is super straightforward. Where is it? Sorry, this one, right? Let me do it. So I think this is the second iteration. Yeah, whatever. .7. What kind of progress is this, right? I don't know. up. I'm calling it a day. Thank you.